A sheet of paper is cut into 8 same-size parts. Each of the parts is then cut into 8 same-size parts, and so on. After the fourth cut, how many of the smallest pieces of paper are there? Now, with each cut, each part is divided into 8 smaller parts. So after the first cut, there will be 8 parts. After the second cut, there will be 8 times 8, or 8 squared, equals 64 pieces. So, if we look at the first cut, the exponent represents the cuts. So 8 to the 1 is equal to 8. 8 to the second power, which is the second cut, is equal to 64. 8 to the third power, 8 times 8 times 8, is 812 pieces. We want to determine how much is it going to be after the fourth cut. So, if we continue this process, it gives us a geometric sequence of 8, 64, 812. So, after the fourth cut, there are 8 to the 4, which is equal to 4,096. So we would say that there will be 8 to the 4th, or 4,096 of the smallest pieces of paper after the fourth cut. Okay, next it says, after the nth cut, how many of the smallest pieces of paper are there? Now, we could see that the value of n is going to be the exponent. So that means that whatever cut n is going to be, it's going to be 8 to the nth power. That's the simple answer. Now let's just show how you would do this by using the geometric sequence formula. So, since this is a geometric sequence, we know that the first term was 8. We know that the common ratio, because you keep dividing each number, is 8. And we want to find out what that nth term formula is going to be. So, here's our geometric sequence formula. Okay, we know that the first term is 8. We know the common ratio is 8, and that's to the power of n minus 1. Now, remember that you have this 8, which has an exponent of 1. This 8 has an exponent of n minus 1. And if you recall from the previous exercises, when you multiply the same base, you add your exponents. So in this case here, it's going to equal 8 to the n minus 1, and then plus this 1 here. Well, minus 1 plus 1 is going to give us 0. So therefore, this becomes an to the nth term is a to the nth, which is what we've already decided it would be. But that's how you would use the geometric sequence formula. Therefore, there are 8 to the n of the smallest pieces of paper after the nth